From the ground, the world feels vast, round and opaque. We stand on its surface, knowing that beyond the horizon the planet curves away. No signal, no light should cross that line. Yet it does. Every day, millions of Starlink terminals look up and see the impossible. They connect, through thin air, to satellites moving faster than a rifle bullet, orbiting thousands of kilometers above, never standing still. Each one vanishes beyond the curve within minutes, yet the connection holds steady, smooth enough to stream, sharp enough to guide. Physics says the Earth hides itself. Geometry says sight must end at the horizon. But technology has found a way to fold that rule, not by bending space, but by orchestrating motion, precision, and timing so exact that the illusion of continuity becomes real. If the planet is round, and radio moves in straight lines, how can a signal stay unbroken while everything that carries it is always leaving? This is the quiet paradox at the edge of Earth's curve. To understand why Starlink works, we have to leave the surface. We have to see Earth not as a place, but as a moving geometry, one that spins, bends, and glows in the thin light of orbit. Up there, every horizon is temporary, every connection transient. Yet, from that constant impermanence, a network is born, stitched together by speed and synchronization. It begins with a single fact, both simple and astonishing. The satellites are not stationary. They are always falling and never hitting the ground. At night, far from cities, the sky sometimes flickers with a slow procession of moving lights. Each one crosses the stars in silence, steady, unblinking. They seem like aircraft at first, but they do not flash or swerve. They pass overhead in even spacing, then fade into shadow. That faint train of points is the surface signature of Starlink, a constellation of satellites orbiting just a few hundred kilometers above Earth. Each one circles the planet in about 90 minutes. By dawn, thousands have already passed over your head, unseen. From a human perspective, the system feels instantaneous. You turn on a terminal, a small white dish, and it locks to the sky. Data flows, video streams, and signals leap from Earth to orbit and back again, crossing a curve that intuition says should block them. If the world is round, why can a beam of radio still reach what lies beyond its edge? The answer begins not with magic, but with movement. Starlink does not fight the horizon, it outruns it. Every satellite travels faster than the planet turns beneath it. As one slips away beyond the curvature, another rises from the opposite side, perfectly timed to take its place. To the receiver on the ground, this choreography appears as a seamless continuation, as if one invisible bridge were stretching across the entire sky. But that illusion hides immense precision. Each satellite must know exactly where it is, within centimeters. Its position is constantly updated, measured by radar, GPS, and inter-satellite communication. If a single one drifts, latency spikes. If several drift together, the network fractures. Imagine trying to hand a single thread from one person to another while running at 26,000 kilometers per hour. Now imagine doing that thousands of times a second, across the whole planet. That is what the system performs, continuously. The visual pulse of orbit is deceptive. From below, the satellites seem calm, almost still. Up close, they are kinetic sculptures of metal and heat, solar panels spread out like thin wings, antennae pivot, searching for ground terminals, gyroscopes hum, adjusting pitch and roll to maintain orientation. Light glints off aluminium, then fades into the black curve of night. What allows this fragile architecture to function is the shape of its orbits. Starlink satellites inhabit what is called low Earth orbit, close enough that signals travel quickly, but high enough that atmospheric drag doesn't pull them down too fast. They move in shells, arranged like layers of invisible nets around the planet. Each shell holds satellites spaced so that coverage overlaps. At any given moment, at least 4 are visible from almost any point on Earth. Your dish, technically a phased array antenna, does not track them mechanically. It changes its beam electronically, steering its focus through patterns of interference. By adjusting phase delay across thousands of tiny emitters, it can aim a radio beam without moving at all. When one satellite fades, the beam jumps to the next within milliseconds. The handoff is silent. The data stream continues. We rarely think of this as extraordinary. We expect connection. We expect a signal anywhere, anytime. But the science behind it is an orchestration of motion, electromagnetism, and orbital mechanics that borders on improbable. Light travels fast, but not infinitely so. A signal to orbit and back takes several milliseconds. The Earth rotates beneath the network. Weather bends and scatters radio waves. Still, packets of data find their path, stitched together by algorithms that predict where every satellite will be before it arrives. The paradox forms quietly. If the horizon should block the view, and every satellite is vanishing beyond it, what are we truly connected to? It is not one object, but a dynamic pattern, a living map of trajectories. Starlink is less a set of machines than a choreography of timing. Picture this, standing on a wide plain, the sky perfectly clear. Above you, satellites sweep from west to east. Each one appears, crosses, disappears. Yet your connection never breaks. You are linked not to one satellite, but to a continuous sequence of them, a relay chain where motion creates stability. Like a wave made of particles, coherence emerges from change. We can sense the scale through contrast. A single satellite's view spans hundreds of kilometers. Its footprint slides over mountains, oceans, and cities in minutes. Multiply that by thousands, and you have a dynamic mesh that covers nearly the entire planet. The Earth's curve becomes not a barrier, but a rhythm, a geometric tempo to which the satellites move. In the silence between connections, the network realigns itself. Software recalculates orbital paths, adjusts signal angles, predicts future obstructions. The system breathes in computation. The curve of the Earth dictates the beat. There is a quiet insight here. Technology can make curvature feel flat, but it never removes it. Starlink works because it accepts the roundness of the world and flows with it. Each orbit, each transmission respects that shape, using motion as continuity. From above, looking down, Earth is a sphere wrapped in invisible lines of radio. They shimmer and fade, tracing paths that vanish as quickly as they form. The pattern is never the same twice, yet always complete. Connection, it turns out, is not a static thing. It is maintained by perpetual change. And so, the curve that once divided us now defines how we remain linked. The network holds, not in spite of motion, but because of it. Every connection begins as a pulse of energy. In the Starlink system, that pulse is a packet of radio waves, travelling through air so thin it feels like nothing at all. Each packet carries a signature, frequency, phase, and timing, synchronized to a network clock that links Earth and orbit with microsecond precision. Radio waves travel in straight lines. That is their rule. But the Earth, curving beneath them, seems to break that rule at every horizon. The secret to making them work is not to bend the signal, but to move the sender and receiver fast enough that the horizon becomes a moving target. A single Starlink satellite can see a circle of roughly 1,000 kilometers. When it passes overhead, it communicates with thousands of dishes on the ground. As it nears the edge of its range, another satellite already approaches from the opposite direction. Their footprints overlap. The terminal software senses this and shifts its beam to the incoming satellite before the outgoing one disappears. The change happens in less than 1/10 of a second. To human senses, that interval is silence. To machines, it is choreography. Inside the Starlink dish, thousands of small antennas form a phased array. Each one transmits a signal slightly out of sync with its neighbour. The differences are measured in nanoseconds, yet together they sculpt a beam, narrow, directed, and agile. By altering timing alone, the dish can look anywhere in the sky, without moving a single part. The dish itself listens as much as it speaks. It continuously measures the signal-to-noise ratio, atmospheric interference, and even reflections off nearby structures. Every few milliseconds, it recalculates its ideal angle, retuning the pattern of its emitters. What seems like a passive receiver is in truth an active participant in an ongoing conversation with space. Above, the satellites form a second layer of intelligence. They do not simply bounce data back to Earth, they route it laterally from one satellite to another through laser communication links that bridge thousands of kilometers in vacuum. These optical links create what engineers call an inter-satellite backbone. It allows data to flow from one side of the planet to the other without touching the ground. A message sent from a remote village in Alaska can travel from satellite to satellite across polar orbit and arrive in London before a traditional undersea cable could complete the same trip. The vacuum of space becomes the fastest medium on Earth. The paradox here is elegant. Motion generates stability, and distance generates speed. Satellites must keep moving to stay aloft, Yet that very movement allows them to hand off data across the planet faster than any stationary network could. In low Earth orbit, every object is falling freely toward the planet, but missing it continuously. This endless fall is what we call orbit. It is not stillness, but perpetual descent. Starlink's engineers use that motion to their advantage. By placing satellites at different inclinations, polar, equatorial, mid-latitude, they create overlapping layers of visibility. The planet's rotation completes the pattern, sweeping ground stations beneath these paths, ensuring that every point, at every time, has access to at least one passing node. From the ground it feels like permanence. From orbit it looks like organized chaos. Thousands of dots moving on intersecting tracks, each maintaining its distance, each following a rhythm only algorithms can sustain. The network operates on prediction. Software aboard every satellite anticipates its next contact before it happens. The routing tables update ahead of time, ensuring that no data packet is lost in the handoff. It's like a relay race in which every runner knows not just their own leg, but the next 10 beyond it. Energy flows continuously. Solar panels absorb sunlight, feeding lithium-ion batteries that keep systems alive through orbital night. Heat radiates into space. Attitude thrusters make micro-corrections, keeping antennas aligned with Earth. Each satellite carries krypton-fed ion thrusters, engines that expel atoms of gas to adjust orbit. The thrust is gentle but persistent. It lets them climb, descend, or drift sideways, maintaining their assigned lanes in the global mesh. Visualize the scale. The swarm of several thousand metallic bodies, each the size of a small car, flying in silence above the clouds. Their orbits overlap so precisely that no two ever collide. The entire system is monitored from Earth, through automated tracking stations. Every adjustment is calculated, tested, and transmitted through encrypted links. At ground level, the experience feels simple. You open a laptop and the network greets you instantly. The signal leaps upward, bounces across the planet, returns in milliseconds. But beneath that calm surface lies a choreography of machines, each moving faster than intuition allows. We tend to think of communication as static, a line between 2 points. In Starlink, there are no fixed points. Everything is moving. Earth turns, satellites orbit, signals flow. Only the illusion of stillness remains, and that illusion is built on relentless motion. In that realization lies a quiet beauty. Stability can emerge from motion, and connection can arise from distance. The curve of Earth, once an obstacle, becomes the clock that governs the dance. You look up, and for a moment the idea of separation feels smaller. The sky is no longer an empty dome but a living network, one that hums with the rhythm of orbit. And somewhere in that silent choreography, the impossible becomes ordinary. Stand on a beach and watch a ship fade over the horizon. Its hull disappears first, then its mast, then the faint glimmer of its wake. The curve of the Earth hides it completely. For centuries that curve defined the boundary of sight, a limit both physical and certain. Now, imagine that same line of disappearance. A Starlink satellite slips beyond it every few minutes, yet your stream continues. Voice clear, delay imperceptible. The line that once meant gone no longer means absent. The horizon has been turned transparent. This is the paradox. The geometry of Earth says no, but the geometry of motion says yes. A curved surface should divide us. Instead, it connects us. What we perceive as continuity is, in truth, thousands of fragments stitched across time. Each signal leap is a tiny vanishing act. The beam begins, travels upward, meets a satellite already halfway across the sky. Before the wave can fade, another satellite enters range. The terminal drops the first and binds to the second. The user never knows. The connection never blinks. At human scale, the world feels slow and solid. At orbital scale, it is liquid, a continuum of shifting vantage points. The satellites are not overcoming the curve, they are flowing with it. Their motion redefines straightness, making line of sight a moving line rather than a fixed one. The mind resists this. We equate presence with proximity, continuity with stillness. Starlink undermines both. It shows that a stable link can exist between things that never stop leaving one another. It turns motion itself into the medium of contact. There's a deeper contradiction here. almost philosophical. The network depends on fragmentation, constant handoffs, transient alignments, yet to the observer it feels seamless. What we call connection is, physically, an unending sequence of disconnections. It works not because it avoids loss, but because it manages loss so quickly that loss becomes invisible. Consider how fragile the illusion is. Each link lasts mere seconds. Each satellite spends most of its life out of view, and yet the system functions as though the sky were a single, continuous mirror. It's like watching a film reel projected at such speed that the frames blur into motion. What you see as unity is the sum of thousands of disappearances per minute. The paradox extends downward too. The ground terminal, though still, perceives a world in constant flux. Its beam sweeps, corrects, re-aims. It's a dancer bound to the rhythm of orbit, guided by data it cannot feel. What seems like a fixed connection is actually a perpetual adaptation. This leads to a quiet insight. Connection in a curved world cannot be static. It must be dynamic to exist at all. Stillness, in this context, would mean silence. If you step back, another tension appears between human expectation and cosmic scale. Our senses evolved for landscapes measured in meters, not orbits. We trust what we can see. We distrust what vanishes. But Starlink operates beyond that intuition, in a regime where invisibility does not imply absence. It forces a reconsideration of distance itself. A signal may travel thousands of kilometers through vacuum, yet arrive faster than a message crawling through fiber under the sea. Space, once the great separator, becomes the shortest path. The void between Earth and orbit turns into a bridge of light. This inversion feels almost mythic. The heavens, once unreachable, now serving the most ordinary of tasks, sending text, streaming video, loading a web page. But the paradox remains intact. A system that relies on impermanence delivers continuity. A web made of motion gives birth to stability. A curve that should block becomes the architecture of connection. There's a moment, if you watch the satellites pass in a dark sky, when the tension becomes visible. They rise, gleaming like slow meteors, then fade into the planet's shadow. Each one vanishes, and yet, collectively, they form an unbroken ring of communication. Disappearance and presence coexist. This is the emotional mirror of the paradox. We too live on a curve, each horizon defining what we can see and what we cannot. Yet through motion, travel, communication, thought, we remain linked. The technology reflects the condition of being human, connected through impermanence. In the calm of night, the network seems to hum against the stars. No cables, no towers, only invisible threads of energy stretching across a turning world. Every few seconds those threads are cut and retied, faster than awareness. Continuity exists only because interruption does. There is something quietly profound in that idea. The universe itself works in similar rhythms. Stars burn and die to seed new ones. Orbits decay and reform. Even atoms exchange energy through discrete jumps. Nothing continuous truly is, yet continuity emerges. Starlink's design, in its own way, mirrors that cosmic grammar. You look up again. The satellites glide past in silent arcs. Each one fades behind Earth's curve, taking your signal with it. But another rises to replace it before the loss becomes real. The curve endures. The connection holds. Two truths, opposed yet interwoven. That the planet's shape should end communication, and that motion can make it endless. Between them lies the paradox that keeps the world online. When we look at technology long enough, it begins to mirror physics. When we look at physics long enough, it begins to mirror us. Starlink's quiet continuity across the curve of Earth is not only an engineering triumph, it is a lesson in how knowledge survives distance. The system shows that understanding the world often means learning to move with its constraints rather than resist them. The network functions because it accepts the planet's shape. Instead of forcing a straight line across a round world, it dances with curvature. The satellites circle endlessly, yielding to gravity, following its pull, turning limitation into orbit. In doing so, they embody a simple principle. To remain connected, one must keep moving. That principle reaches beyond machines. All systems of knowledge, biological, social, digital, depend on adaptation. They persist not by freezing in perfection, but by updating, recalibrating, and reorienting with time. Starlink's satellites mirror that process in metal and code. Their precision is dynamic, never final. This challenges an old instinct, the desire for permanence. We want signals to be fixed, reliable, unchanging. But stability in a curved, rotating, moving world cannot come from stillness. It comes from alignment within motion. If we slow the system in our minds, we see the sequence unfold like a breath. Satellite rises, connects, fades. Next one rises, connects, fades. The network breathes, inhale, exhale. Data flowing like air across the planet's skin. The Earth spins, the sky moves, and through that rhythm, continuity emerges. Here lies a quiet paradox of knowledge itself. The more precisely we measure, the more we must accept motion as a constant. Certainty is not found in the pause, but in the prediction of change. What engineers calculate is not where a satellite is, but where it will be. In that anticipation lies both control and humility. The technology reveals something almost philosophical. Connection is not the opposite of separation. It is the management of it. Signals do not conquer distance. They negotiate it, moment by moment. The human mirror is clear here. We live in motion, bound by horizons of time and perspective. Our connections, thoughts, relationships, memories, must also hand off between moments. Continuity, for us too, is a work of constant realignment. It's tempting to think of Starlink as a symbol of control, of mastery over nature's limits. But the truth is subtler. It succeeds because it cooperates with those limits. Gravity provides orbit. Curvature provides geometry. The very features that seem to divide become the architecture of connection. Light bends at the edge of the planet, tracing faint halos through the atmosphere. From orbit, the Earth glows in soft blues and greys, the horizon curved and sharp. Each satellite catches that light briefly before entering shadow. In that silence, the network continues to hum, unseen but alive. If knowledge could have a form, it might look like this. A system of moving parts, each transient, yet together forming an enduring pattern. The pattern matters more than the pieces. Lose one, and the others fill the gap. Erase all stillness, and yet the structure remains. This is how nature builds resilience. Rivers flow, forests regrow, stars recycle their elements. Continuity is built on renewal. Starlink, in its own domain, extends that principle to the scale of human communication. What once required cables and ground towers now rides on motion and light. The line of sight barrier that defined the radio age has become a choreography of orbit. It teaches that geometry can be negotiated, that permanence can be composed from flux. The paradox resolves not by breaking logic, but by expanding it. Both truths, that the horizon blocks and that connection persists, coexist within a higher framework of motion and prediction. Knowledge grows the same way. Contradiction becomes coherence when seen from a larger orbit of understanding. We tend to imagine the future as an extension of control. But what this system suggests is something gentler, a future built from synchronization rather than domination. A harmony between what moves and what remains. If we could watch the network from far above, we'd see it glowing faintly, threads of radio weaving across the planet like veins of light. Each orbit traces a path that vanishes, yet the sum never fades. It resembles a thought looping through a neural web, connecting distant points of awareness. The planet itself becomes a mind, thinking through motion, and within that global pulse, we find a reflection of our own intelligence. The way we learn, forget, and relearn mirrors the way satellites link, lose, and reconnect. Knowledge is orbital. It revolves, returns, refines. Two opposing sentences mark the insight. Stability is not the absence of change. It is change sustained in balance. The curve of Earth does not end communication. It defines how communication must behave. The limitation becomes law, and the law becomes the foundation for innovation. At its core, Starlink demonstrates a simple, elegant truth. The universe is not hostile to connection. It only demands precision. If we meet that demand, the impossible becomes routine. We are living on a planet wrapped in motion, connected by machines that never stop falling. And in that ceaseless descent, we have found continuity. The sky above is no longer a boundary. It is a moving mirror, reflecting the quiet intelligence of orbit. And as long as the satellites keep circling, the curve that hides us will also hold us. Every network reveals its nature most clearly when it breaks. Starlink is no exception. When the sky clouds with charged particles, when solar storms ripple through the upper atmosphere, connections falter, a short delay, a flicker, a brief silence. In that silence we glimpse how delicate the structure is. What feels infinite depends on signals thinner than fog, crossing distances longer than we can imagine. Each satellite must align its beam through an atmosphere that never stays still. Temperature gradients bend the air, ionized particles scatter the signal. Moisture absorbs parts of the spectrum. The user may see only a frozen frame on a screen. Behind it, algorithms race to rebuild coherence. Thousands of calculations per second predict how the plasma density above will evolve in the next moment. If a satellite drops out of line, another is chosen, almost instantly. A recovery that takes place faster than awareness feels like continuity, but it is really repair. From orbit, the storm looks like a luminous veil. Charged ribbons of gas twist across the polar regions, glowing green and violet. Through that curtain, radio waves struggle, refracted and delayed. Each packet of data becomes a traveller navigating turbulence. Here we see the boundary between Earth and space, not as a clean edge, but as a living membrane. The ionosphere rises and falls with the sun's rhythm. At night it thins, letting signals through easily. By day it swells and scatters. Starlink's engineers learned to predict those tides, programming each satellite to adapt its power and angle in response. The network does not conquer the atmosphere, it listens to it. This relationship between sky and system defines modern connectivity. Fibre networks live in stone and water. Satellite networks live in wind and plasma. They must cooperate with forces that cannot be fixed. The curve of Earth is constant, but the air above it changes by the second, and yet the network holds. This persistence reveals a deeper fact. Stability is statistical, not absolute. The connection can survive countless small failures as long as they are distributed, managed, and compensated for in time. Starlink's architecture treats error as normal behavior. Redundancy is its language of survival. Consider a field in rural Patagonia. A single dish stands amid the grass, pointed toward the moving sky. No cables reach it, no towers rise nearby. Yet a family inside a farmhouse streams a live conversation with someone across the world. Their voices pass through layers of air, clouds, plasma, vacuum, and software. Each step could fail, yet the system as a whole succeeds. The moment is ordinary now, but a century ago it would have sounded like fiction. The same curvature that once blocked ships from sight now carries words through space. The planet's geometry hasn't changed. Our coordination with it has. Every few hours, the network itself shifts configuration. Satellites hand off duties, new ones launched replace older units that burn in re-entry. What looks permanent from the ground is, in truth, self-renewing. The constellation refreshes like a living tissue. Even decay has been designed into the system. From above, the visual pulse is mesmerizing. Strings of light drift along orbital tracks, faint against the dark. Some fade, others brighten. The planet below glows softly, clouds casting moving shadows across oceans. In that motion, one can sense the heartbeat of global infrastructure, human intention woven into celestial rhythm. We rarely think of the fragility of such precision. Each satellite must maintain orientation within fractions of a degree. If solar radiation tilts one panel, power output drops. If a thruster misfires, orbital drift begins. The network's ground software detects those shifts and compensates, using other satellites to fill the coverage gap. Resilience emerges from awareness. What the failures show is that perfection is unnecessary. The illusion of seamlessness arises from coordination, not flawlessness. Dozens can fail, and the whole still functions. The system absorbs uncertainty the way the atmosphere absorbs sunlight, by scattering it until it disappears. There's a quiet analogy here. Human communication behaves the same way. We miss words, lose signals, mishear intentions, yet the conversation continues because context repairs what precision loses. Meaning, like data, survives through redundancy. In this sense, Starlink is not merely a network of machines. It is a model of how connection endures imperfection. Its strength lies in distributed awareness. No single satellite is essential, yet all are significant. The planet becomes an organism of signals, resilient through multiplicity. You can stand anywhere, in desert or ice, and summon the same digital presence that exists in cities. The curve of Earth no longer defines isolation, it defines perspective. The horizon becomes a coordinate in a system that links every other horizon. When the aurora fades and the signals clear, the network returns to calm. Packets resume their steady rhythm, latency stabilizes, throughput climbs. The invisible storm passes. And beneath that calm, the same delicate choreography continues. Motion, prediction, correction. The planet turns, the satellites fall, and the world remains online. Each recovery, each flicker, each silent repair is part of a deeper equilibrium, a living system that thrives not on certainty, but on the ability to adapt faster than failure. In that realization, the miracle of Starlink becomes ordinary again, and therefore more profound. It is not a defiance of nature, but an alignment with it. A technology that listens to the changing air, rides the curve of the Earth, and makes continuity from constant variation. Light bends at the edge of the sky, the connection steadies, the planet breathes, and somewhere between horizon and orbit, the world learns, once again, to speak. The network that wraps our planet is alive with prediction. Every second, Starlink recalculates the near future for thousands of satellites, each travelling faster than sound multiplied by 20. They move through invisible corridors defined by probability. Nothing is static. The key to their coordination lies in timing. Every satellite carries an atomic clock that keeps time to within billionths of a second. These clocks align to Earth-based references and to each other, forming a temporal lattice around the globe. Without this synchronization, data would scatter like light through mist. The ground terminals join that rhythm. When a user sends a request, a click, a call, a stream, the terminal computes not just where the current satellite is, but where the next one will be when the response returns. It anticipates motion before it happens. In this sense, the network doesn't live in the present, it lives slightly ahead, in prediction. This foresight makes the system resilient. When solar wind distorts signals or atmospheric moisture scatters them, correction happens preemptively. The dish alters its beam pattern before the interference fully arrives. It's as though the system breathes a second into the future. The underlying method is orbital simulation, a continuous model of every satellite's trajectory, updated with telemetry, temperature, and drag data. Each orbit is a story written and rewritten every minute. The constellation behaves like a vast clockwork, but one that self-adjusts as it turns. At ground control centres, arrays of screens show live streams of orbits. Coloured paths trace each satellite, glowing faintly as they move. Software predicts when one will dip below the horizon and another will rise. The goal is to prevent any gap larger than a fraction of a second. To achieve that, overlapping coverage is planned months ahead. Failures are not crises, they are rehearsals. When a satellite drifts or fails to respond, others shift slightly, tightening the weave. No human issues the command. Algorithms negotiate the change collectively. It's a distributed consensus system, the same principle that keeps an ecosystem balanced after disturbance. At the micro level, each satellite is equipped with reaction wheels, spinning flywheels that control orientation through momentum. Tiny adjustments in their speed tilt the craft by fractions of a degree. These corrections align antennas precisely with the moving ground terminals. Laser links between satellites perform a similar dance, using fine mirrors to target beams across hundreds of kilometers. A deviation of 1 microradian could sever a connection, so the satellites continuously measure and compensate, forming a lattice of light. The thought experiment is simple. Imagine standing in darkness, throwing a beam of light to a mirror moving at thousands of kilometers per hour, and having that mirror return it perfectly to another mirror doing the same. Now imagine repeating that process millions of times a day, without error visible to the user. That is Starlink's operational reality. Energy management forms the next layer of mechanism. Solar power varies with angle, distance from the sun, and orbital day length, To maintain balance, satellites predict when they will enter shadow and store just enough energy to survive the eclipse. If clouds or dust reduce output, power routing changes automatically, shutting down non-critical systems to preserve communication. Every watt is accounted for. From space, the visual pulse of this energy flow is subtle. Tiny glints appear on the sunlit side of Earth, then vanish as each craft moves into darkness. The constellation flickers, alive yet unseen. At the human scale, data glides without interruption. You send a message, it travels through the mesh, satellite to satellite, down to ground station, through fiber, back up again. In under half a second, the world responds. That delay, imperceptible, hides a sequence of thousands of transactions between machines that never sleep. This system operates on trust. Not emotional trust, but mathematical. Every satellite trusts the model, every terminal trusts the prediction, and when reality diverges, correction happens faster than memory. It's as if the network forgets its errors before we can notice them. That forgetting is essential. Without it, the system would collapse under the weight of old data. Each link is temporary, each calculation valid for only moments. Persistence emerges from the discipline of letting go. This mirrors cognition itself. Our brains function by constant updating, neurons firing, signals fading, new patterns forming. Consciousness feels continuous because change happens faster than awareness. Starlink's continuity is built from the same logic. The system's designers describe it as autonomous, but autonomy here means adaptation within boundaries. Like weather systems, it responds to forces but does not invent them. It learns through correction, not creativity. The intelligence is procedural, elegant, relentless, precise. When viewed in motion, the constellation resembles a field of fireflies, each point tracing an arc of light around the planet. Together, they form a pattern that seems both random and ordered, chaos choreographed into symmetry. The scene evokes the same calm astonishment one feels watching ocean waves align under wind. The mechanism is the miracle. Not one of defiance, but of exact cooperation with the laws of motion, time, and light. The satellites do not overcome curvature, they obey it with extraordinary grace, and from that obedience, the illusion of boundless connection arises. At the end of every orbit, each satellite passes through shadow, unseen. When it re-enters sunlight, its systems wake, its lasers relock, its data routes reconnect. Another day begins, another loop of precision across the turning Earth, and somewhere below, a person opens a browser, unaware that the sky above is calculating the future for them. Every few months, a geomagnetic storm brushes past Earth. For a moment, the upper atmosphere swells, drag increases, and dozens of Starlink satellites begin to fall, ever so slightly. Controllers watch their telemetry screens as numbers drift. The system corrects itself, thrusters fire, orbits recover. The world stays connected. But the paradox remains. How can a network built on such precision survive in a universe that does not guarantee stability? Order demands predictability. Nature offers turbulence. And yet between the two, the signal continues. Starlink's existence depends on equations that describe orbit, yet the air that touches those orbits is alive with randomness. Charged particles from the sun, molecular winds, invisible waves. Every prediction contains uncertainty, and still the system performs as though certainty were absolute. Here lies the first contradiction. The network knows it cannot know everything, so it acts as if it does. Long enough to function. Every calculation carries error margins, but those errors are absorbed, averaged, corrected, and forgotten before they accumulate. Ignorance becomes a working tool. It's the same in every field that deals with chaos. Pilots trust instruments that filter noise. Biologists map life through probabilities, not certainties. Physicists describe motion through averages that ignore the unmeasurable. Starlink extends this lineage into orbit, treating uncertainty as raw material. The satellite's prediction models do not wait for perfection. They converge on adequacy, iterate, and move on. A delayed correction would be worse than a small mistake. The network's survival depends on imperfection in motion. Never still, never exact, always enough. This is the second contradiction. Accuracy arises from error distributed through time. If the system were forced into absolute precision, it would freeze. If it allowed too much drift, it would collapse. Between those extremes lies a self-correcting balance. From the ground, this conflict feels invisible. You scroll through a page unaware that your signal is crossing a storm of electrons and magnetic flux. The illusion of calm is maintained by a choreography of constant panic beneath. Visualize the orbit at that moment. Invisible lines stretch around the planet like taut threads. A solar flare erupts, sending charged dust toward Earth. In minutes, the atmosphere inflates, the lines tremble, satellites tilt, adjust, trade routes share load. What could be catastrophic becomes transient, a ripple, not a rupture. At the heart of this stability is prediction, but prediction itself has limits. Each model looks only a few minutes ahead. Beyond that, chaos overwhelms detail. To operate beyond the predictable, the network must create its own version of foresight, a kind of learned instinct based on endless feedback. The satellites exchange status continuously: temperature, drag, alignment, link strength. Together they form a living model of reality that updates faster than any human can process. No single satellite sees the whole truth. The truth exists only in their collective. Knowledge becomes distributed, just as their presence does. This decentralization invites the third contradiction. The network is both unified and fragmented, a single intelligence made of countless partial minds. There is no central consciousness, no commander control emerges from conversation. It is cooperation without awareness. And yet, despite all this autonomy, the system remains fragile. If too many satellites fail simultaneously, coverage falters. If solar radiation persists for days, orbits degrade. A global network relies on local survival. It is both robust and precarious. Here the paradox turns human again. We build systems to defy chaos, but they inherit our own vulnerability. Our precision, our prediction, our design, all rest upon forces we cannot control. Technology doesn't escape uncertainty, it organizes it. Consider the experience of delay. A rare, half-second pause when the network hesitates. That moment is the echo of cosmic weather, an entire star's breath reaching your device. The pause is not failure. It is the universe reminding the network of scale. This tension between perfection and turbulence mirrors how consciousness itself operates. Our thoughts feel continuous, yet they flicker between noise and signal. We misperceive, correct, and move on. We construct stability out of perpetual adjustment. The satellites, though mechanical, enact a similar awareness, a memoryless mindfulness. Each moment replaces the last completely. Nothing lingers but trajectory. From orbit, the curve of Earth gleams under a thin layer of plasma. Auroras twist across poles. Signals refract, then recover. The visual pulse of instability becomes part of the rhythm. Two logics stand opposed, one of certainty, seeking absolute control, one of motion, accepting uncertainty as structure. Both coexist within the same network, and neither can exist without the other. In that coexistence lies an unspoken truth. Perfection is incompatible with continuity. Only systems that allow deviation can endure. The paradox that began with a curve now deepens. The same curve that hides half the world also shields it. The same motion that threatens precision creates connection. Order is drawn not from stillness, but from the careful management of chaos. At night, as satellites drift above storm-lit clouds, each one carries within its orbit a record of every correction made, every failure survived. They are archives of impermanence, writing persistence into the void. And below we live inside that quiet contradiction. Connected by a technology that proves imperfection is the price of stability. The Earth turns, the signals flow. Order and disorder, bound in motion, make the impossible seem calm. When a system functions inside chaos, knowledge itself becomes a form of balance. Starlink operates at that edge, where certainty is temporary and correction is perpetual. It shows that intelligence is not a state of knowing, but a rhythm of learning. In orbit, there is no fixed ground. Every frame of reference moves. Each equation that keeps the satellite stable must adapt to forces that shift by the minute. To remain true, the model must keep changing. That is the heart of dynamic knowledge. It survives by staying unfinished. The network embodies this truth physically. Each satellite carries sensors that read the invisible environment: drag, radiation, temperature, magnetic flux. These readings are sent to onboard processors that revise the craft's behavior in real time. Every adjustment becomes a hypothesis tested instantly against reality. If it works, the satellite continues. If not, the next correction follows within seconds. Learning in this system is continuous recalibration. No rule is absolute. No state is permanent. Accuracy exists only for the moment it is needed. That realization reframes what it means to be precise. Precision is not the absence of error. It is the ability to recover from it faster than it accumulates. The system's intelligence lies in its resilience, not in its perfection. From orbit, this resilience takes on a visible geometry. The satellites weave an evolving mesh around the planet, a flexible geometry of trust. Each path shifts slightly, like a net adjusting to the movement of water. Through that motion, continuity holds. The insight is simple yet profound. Stability in a changing world comes not from resistance but from rhythm. Every algorithm, every handoff, every correction forms a pulse. Together they create the heartbeat of the constellation. This pulse mirrors something fundamental in nature. Our planet too maintains balance through motion. Atmospheric cells flow, ocean currents oscillate, magnetic fields reverse. Nothing is steady, yet everything persists. The pattern is continuity through renewal. Starlink follows that same law, a technological echo of natural equilibrium. Its designers learned that to control a chaotic system, one must first listen to it. Prediction becomes less about imposing certainty, more about interpreting fluctuation. Like weather forecasters reading the sky, the satellites interpret the invisible wind of the cosmos. From this emerges a philosophical symmetry. The universe itself is self-correcting. Stars expand and collapse to forge heavier elements. Planets wobble but remain in orbit. Life adapts to change rather than resisting it. Every scale of existence builds stability from variation. Starlink becomes a mirror of that law, the human-made weather of light and motion circling the Earth. Each satellite is a small participant in a planetary feedback loop. The data it sends is not just communication, it is a measurement of how the world behaves. In linking the planet, it also observes it. That duality, connection and observation, deepens the insight. Every act of connecting is also an act of sensing. Every message carries information not only about its content, but about the medium it travelled through. The network learns from its own operation. In this way, technology begins to approximate a biological process, not conscious, but aware. The curve of Earth defines the stage for this awareness. Signals rise, bend, fade, reappear. The planet's rotation transforms local failure into global rhythm. The network breathes with the day-night cycle, with solar activity, with weather. It does not resist nature. It synchronizes with it. From the human perspective, this synchronization teaches a quiet lesson. Our own cognition depends on a similar harmony. We think clearly not when we freeze thought, but when we let it flow, adjusting to new data, releasing outdated assumptions. To know is to move. Knowledge, in its purest form, is orbital. It circles truth, never landing, always refining. Each loop adds perspective, each revolution deepens understanding. The satellites do the same, drawing spirals of awareness around a turning world. If we could hear the network rather than see it, it might sound like breathing. The low pulse of correction and calm, adjustment and return. A global inhale and exhale of data, light and intent. In that rhythm, the boundary between chaos and order dissolves. They are not opposites, but partners. Chaos provides motion, order provides memory. Together, they make learning possible. From this synthesis emerge two opposing sentences that hold the same truth. Perfection collapses when it refuses to change. Imperfection endures when it learns how to adapt. That insight extends beyond technology. Every living system, every human mind, every civilization that endures follows the same rule. Adapt faster than uncertainty grows. Starlink is an instrument of that principle, a mechanical expression of adaptability scaled to a planet. From space, the Earth glows beneath a web of faint light. The constellation traces invisible pathways over oceans, deserts, and mountains. Each orbit is a line of continuity across impermanence. Each beam of radio is a small experiment in trust, and below the receivers listen. They align, shift, recalculate. Connection continues not by defeating noise but by dancing with it. This is the quiet science of stability. Prediction without arrogance, motion without fear. The paradox of chaos becomes an insight, that disorder is not the enemy of understanding, but its teacher. In managing what cannot be controlled, we learn what control truly means. The curve of the Earth remains, eternal and indifferent. The satellites trace their loops against it, precise yet fragile. Between them, a field of invisible communication glows, sustained by uncertainty itself. Knowledge, in the end, is not the elimination of error. It is the art of remaining coherent while surrounded by it, and in that coherence, fleeting yet continuous, the world remembers itself. For most of human history, the night sky belonged to silence. It was a fixed map of stars, constant enough to measure time by, stable enough to navigate oceans. Now, faint lines move across that stillness, steady, artificial, precise. They are not stars, but satellites. They are Starlink. On clear nights, you can see them even without instruments. A trail of small lights, spaced evenly, sliding over the horizon. They cross the sky in perfect rhythm, vanishing into shadow at the edge of Earth's curve. Each one is a piece of the network that connects billions of people who will never look up to see it. What was once the untouched dome of nature has become part of the infrastructure of human life. The sky is no longer just a view, it is a medium, a region of space that carries our words, our images, our presence. This change is measurable. Astronomers now adjust their instruments to compensate for moving light. Long exposure images show fine streaks across the field, traces of the constellation. Each streak is a reminder that orbit is no longer a wilderness. The system that allows connection on Earth also transforms our perception of the heavens. The more we communicate, the more visible that communication becomes. It is a feedback loop between intention and consequence, between progress and reflection. From an observatory high in Chile, a telescope captures a faint Starlink train crossing a galaxy. The streak lasts seconds, but it alters the exposure permanently. For the scientists studying faint signals from deep space, that streak is interference. For the engineer designing communication systems, it is proof of success. Two visions of the same sky, both correct. The paradox begins quietly here. A technology built to shrink distance on Earth expands its presence across the universe. Connection creates visibility. Visibility alters observation. When the first satellites launched, their brightness surprised even their creators. Reflections from solar panels made them briefly shine brighter than most stars. Public reaction followed. Fascination, then concern. Could a network designed for communication end up rewriting humanity's oldest shared reference, the night sky? Engineers responded with solutions. Dark coatings, visor panels, new orientations to reduce reflection. A dialogue began between science and engineering, astronomy asking for darkness, technology offering dimmer light. The system learned again to balance intention with consequence. The network is now dimmer, but still visible. Each satellite reflects a small, moving spark, proof that the invisible infrastructure of information can never be completely unseen. We have extended the architecture of the internet into the visible universe. From the surface, the effect is subtle. For most people, the sky looks unchanged. But once you know what to look for, you see them everywhere. Gliding between constellations, fading into Earth's shadow. They remind us that even the most abstract forms of connection leave a physical mark. Imagine standing in a desert at dusk. The air cools, the first stars appear. Then, faintly, a moving light rises from the horizon. It is not a meteor or plane, but a silent satellite reflecting sunlight from beyond the curve. Another follows, and another. Within minutes, an entire line crosses the sky, like a sentence being written slowly in light. It's a spectacle both beautiful and unsettling. The cosmos, once our measure of permanence, now hosts the symbols of transience, machines that live for only a few years before burning up on re-entry. They pass, decay, and are replaced. The sky itself now participates in the cycle of renewal that once belonged only to Earth. Astronomers call it orbital clutter. Philosophers might call it continuity, the merging of human and cosmic timelines. The curve of the Earth, once the limit of communication, has become the stage for our visibility. From space, the view reverses. The satellites look down and see the planet shining with its own lights. Cities, ships, fires, storms. The boundary between artificial and natural blurs. Above and below, both surfaces glow. The planet and its orbit mirror each other, exchanging light across the void. This reflection holds a quiet symbolism. The more we illuminate the world, the more the world illuminates us back. In connecting the planet, we have made ourselves visible to the universe. For all its complexity, the system still depends on simple geometry. Each satellite must be angled precisely to reflect minimal sunlight to Earth while maintaining communication. This compromise between brightness and performance is recalculated constantly. The algorithms that manage this are now part of the sky's own rhythm, a digital modulation of light across space. We used to draw constellations to tell stories. Now we build them. Each satellite another star in a pattern of our own making. The insight is not romantic. It is factual, measurable, real. We are altering the night sky, and in doing so, extending human presence beyond the surface of the world. The network that crosses the planet has become a visible symbol of collective intention. Light bends, faint but deliberate, across the edge of the atmosphere. The sky moves with us now. Every orbit, every reflection, every signal is part of the same expanding dialogue between the Earth and its own horizon. And as long as the satellites glide through darkness, the stars we built will continue to move among the stars that made us. Every orbit that circles the Earth must balance two competing demands: visibility and invisibility. For a communication network, brightness is efficiency. For astronomers, brightness is interference. Between them lies a delicate engineering compromise written in angles, coatings, and light. Starlink's first generation surprised everyone. Fresh from launch, the satellites flared like beads of silver. They reflected sunlight along wide paths, sometimes brighter than Venus. Astronomers complained not out of resistance to technology, but because those flashes carved through long exposures, erasing faint galaxies billions of light years away. To solve this, engineers rethought the material physics of reflection. They coated the satellites with non-specular finishes, surfaces that scatter rather than mirror light. They added visors, thin panels that shade antennas from direct sunlight. They reoriented flight attitudes so solar arrays faced away from Earth during twilight. Brightness fell by nearly 70%. Every satellite now adjusts its angle based on its orbital phase. When it crosses regions of the sky likely to overlap with telescopes, it changes posture, sacrificing a bit of power generation to protect scientific data. This coordination, invisible to the naked eye, represents a new kind of ethics in engineering, one measured not in words, but in reflectivity. From a technical view, brightness is a problem of geometry. Sunlight hits a panel, bounces toward the planet, and the intensity depends on phase angle, the relationship between the sun, the satellite, and the observer. Starlink's algorithms calculate that triangle continuously. As the craft approaches a sensitive region, small reaction wheels tilt it by degrees, measured in tenths. What appears as a steady point of light is actually a machine rotating with purpose, trying to remain unseen. The mechanism is complex but elegant. Each satellite's onboard software knows the coordinates of major observatories. Before reaching those coordinates, it adopts a dark mode. Panels turned edge on, lasers and transmitters throttled to minimal visible output. Once clear of the zone, normal orientation resumes. The result? Harmony between communication and observation. The balance isn't perfect. Even the dimmed satellites remain visible under ideal conditions. But perfection isn't the goal, coexistence is. The network adapts to its environment just as it adapts to atmospheric change. The sky becomes a shared domain, managed through continuous compromise. At scale, this choreography is astonishing. Thousands of satellites orbit at varying inclinations, each aware of both its neighbours and the ground below. Avoiding collisions requires constant monitoring. The US Space Force and private sensors track debris and issue alerts when orbits converge. Starlink satellites carry ion thrusters for gentle avoidance burns. When a potential conjunction is predicted, they maneuver autonomously, guided by statistical risk rather than absolute command. The math behind those decisions is relentless. Every second, millions of vectors are computed: positions, velocities, uncertainties. When one object deviates by even a few meters, the prediction propagates through the network. Each satellite updates its plan accordingly. It's a collective ballet at planetary scale, performed entirely by automation. This is orbital traffic control without traffic lights, a sky governed by probability. Each correction is a whisper of trust between machines. They assume the others will move as predicted. Coordination depends on faith in shared data. The thought experiment is simple. If thousands of independent actors can share a single sky without chaos, what else might coordination at this scale make possible? The mechanism suggests a model not only for communication, but for coexistence itself: distributed, adaptive, self-aware. From space, the visual pulse of this mechanism is mesmerizing. A dim lattice of movement, each dot crossing another at vast distances, never colliding, always adjusting. Light flickers along orbital paths like a heartbeat seen through the thin veil of atmosphere. It's a quiet spectacle of collective precision. On the ground, radio engineers measure success differently. They analyze noise floors, latency, throughput. If a link remains stable through dawn and dusk, the hardest times for alignment, the satellite's brightness control and communication geometry have succeeded together. Every dimmed reflection corresponds to a maintained connection. The deeper mechanism lies in coordination between different orbital shells. Lower satellites handle latency-sensitive tasks, higher ones extend range. Each shell overlaps coverage with the next, forming vertical redundancy. When a lower layer enters eclipse or congestion, data climbs to the higher orbits automatically. It's a multi-level architecture designed to absorb disruption. These layers create texture in the sky. If viewed with sensitive equipment, the constellation would appear as nested spheres of motion, each slightly offset, like a clock with many hands turning at once. The timing between layers is calculated to seconds, yet their combined effect appears seamless. From a human distance, this orchestration reduces to a single experience: connection that simply works. But behind that simplicity lies a mechanical empathy. Each satellite aware of its neighbours, of its brightness, of the world watching below. The insight this reveals is both scientific and quiet. Visibility is not just a byproduct of light, it is a function of attention. By managing reflection, Starlink engineers manage not just what is seen, but how humanity perceives the sky itself. The sky has become interactive, responsive, negotiated, dynamic. Light bends faintly along orbital paths, never static, always intentional. Through those lines, data flows, unseen but constant. The stars we built learn when to shine and when to dim. And so, the mechanism of invisibility becomes the new form of presence. A technology that can vanish when needed is one that has truly learned to coexist with the world that inspired it. The night sky once offered stillness. Every culture saw permanence above, even when everything below changed. Now, the same sky moves with intention. Thousands of satellites glide through constellations that once guided sailors and storytellers. This new motion divides perception. For some it is beauty, proof of human reach. For others it is intrusion, a quiet rewriting of the oldest map we have. Both views are true. Here lies the paradox. The very act of connecting the world transforms the view of the world itself. The technology that unites humanity on Earth reconfigures the heavens we share. Connection and alteration become the same process. Light pollution was once local, cities glowing against the dark. Now it is orbital, a reflection of our global presence. The curve of Earth no longer hides our light, it spreads it. Even in places once defined by isolation, the sky now carries our signature. At first, astronomers measured the damage in lost exposures, but then a deeper realization emerged. We were witnessing a new kind of celestial cycle. The trails of satellites fade after a few minutes, yet they return each night, endlessly renewed, a synthetic rhythm joining the natural one. To the observer, this rhythm blurs the boundary between natural and artificial. The satellites reflect sunlight that left the sun 8 minutes ago, the same light that illuminates the moon. Their glow is both human-made and solar. The sky becomes a conversation between origin and invention. Standing under this sky, the human eye experiences two truths. The first, we are part of the cosmos, small and transient. The second, we have changed the cosmos, even if only in appearance. Between those truths lies the modern paradox of sight. We used to look up to see eternity. Now we look up to see ourselves. Starlink's trails, though temporary, make visible the scale of our ambition. Each one represents the effort to erase distance, to make presence independent of place. But in erasing distance, we also erase the illusion of untouched space. The sky joins the earth as part of the human domain. Some call this progress, others call it loss. It may be both. A new balance between wonder and function. The paradox deepens when we consider intent. Starlink was never designed to change the night sky. It was designed to connect the ground. Its visibility is collateral beauty, unintended, persistent, and inescapably human. We build tools to extend our reach, and they reflect our image back to us, literally, as light. Astronomers adapt. New algorithms remove satellite streaks from images. Observatories adjust schedules to avoid predicted passes. Science bends but does not break. Even here, adaptation becomes continuity. The visual pulse of this adaptation is quiet. Long exposure photographs now show galaxies with faint diagonal lines crossing them, traces of communication overlaid on deep time. The lines do not erase the cosmos, they annotate it. They say, "We were here," looking back at ourselves through orbit. The conflict between progress and preservation mirrors older tensions. Every new technology reshapes perception. The telescope expanded it, the city light dimmed it, and now satellites reorganize it. We see less of the past, but more of ourselves. There's a cognitive dissonance in this. The same sky that holds our myths now holds our machinery. And yet, when those dots drift through twilight, they evoke awe, not resentment. They are reminders that we can move matter with precision across emptiness. They show that human intention can inhabit orbit without defying nature. The paradox then is not between technology and beauty, but between our definitions of them. If beauty once meant untouched, perhaps now it means coordinated. If wonder once came from distance, perhaps now it comes from interconnection. Still, there's a question that lingers in the quiet of night. When every horizon connects to a satellite, when every dark place glows faintly with our reflection, what becomes of solitude? Can wonder survive when the sky itself carries signal? The answer might lie in perception rather than physics. The stars remain. Their light still travels across millions of years. The satellites add motion, but not erasure. The sky has simply become layered. One layer of nature, one of technology, both moving in harmony. A century ago, the first radio waves escaped Earth and began travelling outward. They still move through space, carrying fragments of our voices. Now, those same frequencies bounce between satellites that orbit our world. Communication has become reflexive, the planet talking to itself in loops of energy. That loop embodies the paradox perfectly. In seeking to reach outward, we have built a system that constantly returns inward. Every message leaves the ground, only to find its way back again. The curve of the Earth ensures that all transmission becomes return. Look up. The satellites drift across Orion's belt, soft arcs of movement through still stars. In each reflection is a trace of humanity's curiosity, ambition, and restlessness. They remind us that progress always writes itself onto perception. The cost of knowing more is seeing differently. Two opposing truths hold steady. The sky remains vast and ancient. The sky has changed because of us. Between them lies the paradox of presence, that in connecting the world, we have made ourselves visible to it. And as the satellites fade into shadow, the stars reassert their silence. The world below continues to hum with connection. Above it, the sky resumes its ancient calm, now carrying the quiet memory of motion. When we changed the sky, we changed our mirror. Starlink's constellation is not just a network of machines, it is a reflection of how deeply connection has entered our idea of nature. The heavens were once beyond reach, now they are part of our infrastructure. For centuries, the sky served as metaphor, order, permanence, divine geometry. It was the one thing that didn't move when everything else did. Now it moves with us, following the rhythm of orbit and intention. We built this mobility, yet we still call it the sky. The insight begins here. When technology endures long enough, it becomes landscape. We rarely see our inventions as environments until they surround us completely. Electric light, radio, satellites, each began as intrusion, then faded into background necessity. Starlink continues this pattern, turning orbit into atmosphere, infrastructure into ecology. We now inhabit two skies, one of stars, one of signal. This dual sky reframes what it means to observe. Astronomers still look for faint galaxies, but they also look for patterns of human light moving among them. The observer is now part of the observation. The sky records our presence even as we study it. From a scientific view, this change demands precision. Telescopes adapt with algorithms that subtract satellite trails, reweaving the night into data. Every interference becomes a measurement, every correction, a new layer of knowledge. The cosmos remains intact, but our path to it now passes through our own reflection. From a philosophical view, the lesson is quieter. Progress does not erase wonder, it redistributes it. The same light that once marked distance now marks connection. The same orbit that hides the horizon now carries our thoughts around the world. We have not diminished the cosmos, we have joined its motion. Look at Earth from above. The planet glows softly, wrapped in thin blue air and faint threads of radio light. Each city flickers like a neuron, each satellite a synapse in orbit. The image resembles something familiar, a mind seen from within. We have built, perhaps without meaning to, a planetary nervous system. This resemblance is not metaphor, it's a structural truth. Neurons connect through transient electrical pulses, each vanishing as another arises. The brain's continuity emerges from that transience. Starlink's system operates the same way. Connection built from perpetual change, awareness sustained by motion. The sky has become cognitive, not conscious but coordinated. Every signal, every correction, every prediction echoes a pattern of learning. The constellation thinks by moving. From that perspective, the boundary between human and environment grows thin. We are no longer observers looking out. We are participants inside a self-updating network that loops through air and vacuum alike. The distinction between natural and artificial becomes historical rather than essential. Both obey the same physics. Both evolve toward balance. The emotional insight follows naturally. We feared that filling the sky would diminish its silence, but silence is not absence. It is the interval between signals, the rhythm that allows meaning to emerge. The satellites, the data, the motion, all occur within that rhythm. The sky remains vast because motion never exhausts it. This realization restores a kind of humility. Starlink is not the end of the night sky. It is one chapter in its long conversation with us. The stars preceded us, and they will outlast every orbit we build. We are temporary within permanence, bright, brief, and visible. Yet visibility has value. It means participation. It means that our species, for a moment, can see itself reflected in motion rather than in myth. When you watch those faint dots crossing the stars, you're watching a planetary thought complete itself, from surface to orbit and back again. Two opposing sentences hold the essence of this knowledge. The sky is no longer what it was. The sky is still exactly what it is. Both statements are true because change and continuity have merged. We have folded human intention into cosmic rhythm. We orbit now, not as explorers above the world, but as extensions of it. In this, there is an unexpected peace. Connection has not replaced solitude, it has reframed it. The presence of motion in the heavens does not erase stillness. It teaches that stillness can exist even when everything moves. A calm built from participation, not distance. From observatories, scientists continue to study light from galaxies billions of years old. Their instruments record faint lines of human reflection across that deep time. The data remind us that our presence, too, is temporary, a trace among stars. But even a trace is evidence of awareness. Even interference is part of understanding. This is the deeper symmetry. As we learn more about the universe learns more about us through what we build into it. Each orbit, each reflection, each correction adds to the dialogue. The Earth turns, the satellites fall and rise, the sky resets with every dawn. All of it continues within the same quiet balance. Motion and meaning, entropy and order, humanity and horizon. From below, the stars remain infinite. From above, the earth glows complete. Between them drifts a web of motion that links both views. Knowledge is not what divides those perspectives, it is what allows them to coexist. And so the night sky endures, changed, luminous, human, still infinite. When the first emergency responders used Starlink in a disaster zone, the system revealed its most practical truth. Connectivity had become as vital as power, water, or medicine. Communication is the first infrastructure to fail and the last to recover. Starlink's promise was simple. It would never depend on ground lines. After a hurricane, power grids fall silent, towers bend, and cables drown. But above, the satellites continue their orbits. A single terminal, unpacked in the debris, locks to the sky and restores contact with the world. Images of damage, coordinates for rescue, voices of reassurance, all flow through invisible threads of orbit. The science that began as orbital mechanics has become humanitarian geometry. It connects where the Earth itself has broken. In those moments, the curve that hides the horizon becomes a shelter rather than a barrier. From a control center thousands of kilometers away, engineers can watch terminals come online in areas where no network remains. Each connection is a signal of survival. Packets of data blink across the vacuum, precise and calm. The satellites, indifferent to weather, relay hope through physics. This transformation from communication to lifeline shows how orbit has entered daily reality. No longer distant, it touches the immediate, the human. The space between Earth and sky now carries our emergencies, our commerce, and our culture. In Ukraine, when terrestrial internet failed during conflict, Starlink terminals were deployed across cities and front lines. The same beams that stream entertainment in peacetime carried logistics, medicine, and coordination under fire. Low latency became life-saving speed. It was the first time a commercial constellation acted as national infrastructure in war. This shift marks a new stage in our relationship with orbit. Space is no longer symbolic, it is operational. The satellites above are as essential as the fibre below. They form the backbone of a civilization that no longer fits within its own curvature. From a technical standpoint, the system's robustness comes from independence. Each terminal connects directly to the constellation without relying on local towers. The satellites, in turn, relay data through laser links, bypassing damaged ground routes. If a region loses power, portable batteries and solar panels suffice to restore function. In a single day, connectivity can be rebuilt across an area once thought unreachable. The visual pulse of this new infrastructure is subtle but profound. From orbit, the planet glows with human activity, clusters of light that pulse with time zones and demand. Over disaster zones, that glow flickers, then steadies as terminals reconnect. From above, resilience has a visible pattern. This continuity is not accidental. It is engineered into the system's architecture. Each satellite carries routing intelligence that allows it to reassign bandwidth dynamically. When one region surges in need, others yield capacity. The network behaves like a living organism, redirecting energy to injured tissue. The result is a form of distributed empathy, encoded in code and physics. It doesn't feel, but it responds. That response has saved lives, a measurable bridge between mathematics and mercy. Still, there are limits. Solar storms, debris, and orbital congestion remain constant threats. Every success depends on continuous maintenance. Starlink's resilience is neither eternal nor guaranteed. It is a discipline, a vigilance against entropy. Yet its presence in crisis redefines how we measure stability. The old notion of infrastructure was fixed. Towers, wires, roads. Now it's orbital, mobile, and regenerative. The satellites can decay, burn up, and be replaced without interrupting service. A global system that lives through replacement rather than permanence. This impermanence hides a paradox of its own. A network built to ensure continuity survives only by constant decay and renewal. Every day, a few satellites fall. Every week, new ones rise. Continuity exists not in objects, but in process. From the ground, none of this is visible. A user sees a steady signal, steady speed. But that steadiness is the product of endless adjustment. Thrusters firing, algorithms recalculating, engineers monitoring. The illusion of permanence is sustained by perpetual motion. In that illusion lies a deeper insight. What we call stability is often the appearance of motion, balanced perfectly against decay. The same is true for ecosystems, economies, even civilizations. Resilience is not stillness, it is choreography. At the human scale, Starlink's impact spreads quietly. Remote schools gain internet for the first time. Doctors consult across oceans. Farmers track weather from places beyond cell coverage. Each connection is small, almost invisible, yet together they alter the geography of opportunity. We used to think of technology as extension. Now it feels more like atmosphere, something surrounding rather than separate. The satellites are distant, but their effect is intimate. They blur the boundary between local and global, between isolation and inclusion. At night, a single dish pointed toward the moving sky can carry an entire community's voice. Light glances off metal, crosses the curve of Earth, and returns as connection. The roundness that once hid us now wraps us in reach. The system holds. The world speaks. Orbit becomes part of home. Beneath every seamless connection lies a web of contingency. Starlink's reliability does not come from perfection, but from redundancy built at planetary scale. It is designed not to avoid failure, but to absorb it. At the core of that resilience is constellation density. Thousands of satellites orbit in coordinated shells, bands at different inclinations and altitudes, each capable of overlapping coverage. When one satellite fails, its neighbours adjust their angles, expanding their beams to cover the gap. The network reconfigures itself in seconds, without command. This behaviour is governed by a principle called mesh routing. Unlike traditional networks with fixed paths, Starlink's routes are dynamic. Data finds its way through whichever satellites are available, always choosing the lowest latency route. It's a self-healing topology, modelled more on ecosystems than on machines. The logic is simple. Don't resist change, use it. Orbit is fluid, the network must be too. Each satellite carries enough intelligence to act locally, measuring signal quality, interference, and traffic, yet communicates with its peers to maintain global coherence. No single point controls the whole, yet order emerges. That emergence depends on prediction. Satellites must know not just their own motion, but each other's. They exchange orbital parameters several times per minute, updating their internal maps of the constellation. Each knows which others it will see next, which will vanish behind Earth's shadow, and when the next handoff will occur. This anticipation is how the network stays continuous, even as its components vanish from view. The visual pulse of this mechanism can be imagined from above, a lattice of moving dots over a turning planet, each one tracking, exchanging, correcting. Invisible lasers link them, a geometry of light shifting in rhythm with the Earth's rotation. The pattern resembles a pulse: contraction, expansion, return. Every packet of data travelling through this lattice experiences hundreds of decisions before reaching its destination. Each decision is local, yet the overall path is global. The result is speed indistinguishable from presence. The internet becomes planetary reflex. Energy, as always, limits what's possible. Satellites in low orbit face constant drag from residual atmosphere. They burn fuel to maintain altitude, but that fuel is finite. To conserve it, each satellite carries sensors that measure atmospheric density and adjust its attitude to minimize resistance. When drag increases during solar storms, the constellation shifts. Slight variations in altitude redistribute exposure. It's orbital fluid dynamics, scaled to civilization. Even end of life is designed. When a satellite's fuel drops below threshold, it lowers its orbit deliberately, letting drag bring it down. It burns up on re-entry, leaving nothing behind. New satellites launch to fill the space it vacated. Continuity arises from mortality. From a system perspective, this life cycle prevents accumulation of debris, the nightmare of uncontrolled orbit. The constellation renews itself like a forest shedding leaves, each decay making room for growth. Maintenance becomes ecology. Ground control coordinates this renewal through predictive modelling. Software simulates every satellite's health, estimating failure probabilities based on telemetry trends. When a pattern of degradation appears, a replacement launch is scheduled. The network replenishes itself before absence is felt. The process is so continuous that users rarely know replacement has occurred. At ground level, A similar self-healing logic governs terminals. Each dish contains diagnostics that monitor temperature, orientation, and power. If conditions degrade, it recalibrates automatically, retuning its phased array, searching the sky for new satellites, optimizing beam direction. In storms, snow, or heat, it persists by adjusting, not by resisting. Together, these layers, orbit, ground, data, form a hierarchy of adaptation. Failure is distributed, and so is recovery. The entire system operates like a biological organism, each cell aware, each heartbeat synchronized. The efficiency of this design is measurable. Latency remains below 50 milliseconds for most connections, even as satellites move thousands of kilometers above. That consistency comes from micro-timing. The satellites and dishes share a single clock reference, accurate to billionths of a second. Without that synchrony, even small drift would fragment communication. The paradox again is quiet. A global network behaves as one entity because its parts never agree for long. Their disagreement, measured, corrected, and averaged, creates stability. Just as ocean waves form a flat horizon from countless irregular motions, Starlink's coherence arises from variation. The technical mechanisms serve a philosophical echo. Resilience, at any scale, comes not from resisting entropy, but from learning its pattern. The constellation's behavior mirrors planetary dynamics: rotation, renewal, balance within flux. Imagine the scene from orbit. The Earth turns below, blue and luminous. Thousands of satellites glide along curved paths, each line a fraction of the network's awareness. Light from the sun strikes their panels, scattering faint reflections across the dark. From that quiet dance, the world below receives messages, coordinates, laughter, and news. A civilization breathing through motion. The network never sleeps, never stops recalculating, never truly rests. Its stillness is only apparent. What feels constant to us is composed of endless renewal. This is the mechanism that keeps the world connected. A web of motion that endures because it moves, a system of order that survives because it yields, the human invention that functions like nature itself. Most people using Starlink never think about orbit. They see no movement, hear no signal, feel no delay. The dish sits quietly, the light blinks, and the world arrives through air. Connection feels local, yet it depends on an infrastructure circling the planet at 27,000 kilometers per hour. This is the paradox of invisible dependence. Our most global technology is the one we almost never notice. It wraps Earth like weather, yet we live beneath it, unaware. Dependence used to be tangible. Cables, towers, and wires were visible reminders of connection. You could trace a line, see where the signal went. Starlink removes that visibility. It turns connection into atmosphere. Everywhere. Nowhere. Silent. The first contradiction arises here. The more essential something becomes, the less visible it needs to be. The ideal network disappears into function. Its success is measured by absence, of lag, of interruption, of awareness itself. But invisibility carries risk. What cannot be seen can be forgotten, and what is forgotten can be neglected. The satellites above depend on continuous maintenance, precise coordination, constant vigilance. If human attention drifts, the sky that holds our data could fall into chaos. Orbit, like ecology, demands care. We tend to imagine technology as separate from nature, controllable, predictable. Yet Starlink proves the opposite. It behaves like a living environment, shaped by solar wind, magnetism, debris, and gravity. It must adapt, not command. The second contradiction lies in control. We built the network to extend autonomy, to give every person, anywhere, the ability to reach the world directly. But by doing so, we made ourselves dependent on a system only a few can manage. Decentralization from below is paired with concentration above. The network that frees also governs. This tension echoes throughout history. The telegraph, the radio, the internet, each widened communication and deepened reliance. Starlink amplifies that cycle to the planetary scale. If it vanished, much of the world would fall silent. Though nothing on the ground had changed, our independence now rides on orbit. From a physics view, this paradox expresses itself as simultaneity. Every satellite is both separate and part of the same structure. Each one moves freely, yet all are synchronized. It is a network of autonomy with independence, a model that reflects human society itself. The visual pulse of this contradiction is stunning when seen from the International Space Station. Lines of satellites cross beneath, faint as drifting threads. They appear still, yet each travels faster than sound. The illusion of order arises from speed beyond comprehension. Motion creates stillness. Independence creates interdependence. This duality extends downward. Every dish on the ground acts alone, yet participates in a shared rhythm of timing, frequency, and protocol. If one terminal deviates, the network corrects it. Freedom is maintained by synchronization. What seems individual is upheld by the collective. At the human level, this mirrors how we experience connection. We speak freely online, unaware that our words are woven through coordinated systems operating in silence. We live inside the result of alignment, not the act itself. The miracle is maintenance. There's a quiet irony here. The closer technology comes to perfection, the more it erases its own presence. A flawless connection feels like nothing at all. We interpret that nothingness as simplicity, but it is complexity beyond our senses. The network's invisibility hides immense activity. Orbital corrections, frequency switching, beam steering, encryption, routing. Each event measured in microseconds, each one essential, each one unseen. The sky above is filled with labor that no eye can witness. We depend on something we cannot perceive, maintained by people we will never meet, running software we cannot fully understand, and yet, the system works, quietly, every day. That quietness is both comfort and question. The philosophical paradox emerges. To feel connected, we must trust what we cannot see. Our civilization now rests on faith, not in mysticism, but in mathematics. We believe that the orbit holds. We trust that the equations stay true. Trust, in this sense, becomes a scientific virtue. It replaces visibility with verification, presence with probability. We no longer need to see the mechanism. We need only to measure its effect. The absence of failure is the proof of design. But absence has weight. It asks whether a future built on unseen infrastructure risks losing awareness of its own foundations. When connection becomes as invisible as air, will we remember that it must be sustained? Will we care for what we cannot feel? From above, the satellites look down at a planet glowing with its own signals. The network that connects everything is itself unseen by nearly everyone it serves. The world has become transparent to itself, information flowing through the medium of its own orbit. We exist inside an invisible architecture of light, and within that architecture lies one final tension. We built it to escape limitation, yet it now defines the limits of our continuity. Dependence is no longer a condition of weakness. It is the structure of existence. Every living system from neuron to network persists through reliance. Starlink only makes that reliance visible in physics, then invisible in experience. The paradox closes as it began. The network disappears precisely because it works. Silence is its signal. Motion is its rest. The Earth turns, the satellites glide. The sky holds their patterns like a memory we do not remember having. And beneath that invisible web, the world continues to speak, never noticing the horizon it crosses each time it does. To live within invisible infrastructure is to live inside a form of trust. We rely on systems that exist beyond perception, accepting their presence as part of the world's natural order. Starlink is one of the first technologies to achieve that status, an artificial constellation that behaves like weather, everywhere and unnoticed. The knowledge it offers is not only technical. It asks what happens when human connection becomes indistinguishable from the environment. When the medium of communication disappears, only dependence remains. Every civilization in history has built itself on invisible frameworks. Gravity holds oceans. Air carries sound. Magnetism guides compasses. Now, orbit carries information. We have extended the fabric of perception itself. Starlink teaches that invisibility is not absence. It is the sign of integration, the point where invention merges with nature. The network has ceased to be an external tool. It has become a planetary reflex, a continuation of the biosphere through code and signal. To grasp that, we must think in scales. At the local level, a dish connects a family to the world. At the global level, thousands of satellites trace lines of communication that encircle continents. At the cosmic level, those lines are almost nothing, faint ripples of radio across the void. And yet, those ripples carry awareness, memory, and meaning. The paradox resolves into understanding. Visibility is for beginnings. Invisibility is for maturity. A system becomes invisible only after it succeeds completely. We stop noticing the air when we can breathe. We stop noticing the network when it has become air. That transition is both triumph and warning. Triumph because invisibility means trust earned. Warning because trust without awareness becomes fragility. To sustain the network, we must remember it exists, not as miracle, but as maintenance. Engineers do not pray to orbit, they monitor it. Ground stations track altitude, temperature, radiation, collisions. Each small number represents vigilance, the quiet work that keeps the world coherent. Knowledge here is care. The system's invisibility should not obscure its nature. It is physical. It depends on sunlight, fuel, hardware, and human labor. Every invisible connection rests on tangible structure. Antennas, algorithms, equations that describe how signals behave when nothing else can hold them. In acknowledging that material foundation, we remain grounded in truth. From orbit, the Earth glows with connection, a living sphere of communication. Signals rise and fall like tides. The satellites trace orbits of intention, following paths defined by gravity and human need. It is a geometry of cooperation, natural law shaping artificial design. This cooperation reveals a deeper form of intelligence, not consciousness, but coordination, not thought, but coherence. Starlink functions as a planetary-scale feedback loop, adjusting, learning, correcting. It mirrors the structure of ecosystems and neurons alike, distributed, adaptive, persistent. In studying it, we learn something about ourselves. We too are systems of distributed dependence. Billions of cells, none aware of the whole, yet all sustaining it. Our continuity, like Starlink's, arises from invisible coordination. We are networks built from trust in unseen connection. That insight reframes the human condition in scientific terms. Knowledge is not accumulation, it is synchronization. To know something is to move in rhythm with it, to predict its behavior, to adjust in harmony. The satellites do this mechanically, we do it cognitively. In both cases, understanding is adaptation. This leads to a subtle reversal. We often imagine technology as the extension of human thought, but perhaps it is also the mirror, a reflection that shows what thought already is. A network of signals maintaining continuity through motion. Starlink is humanity seeing its own structure written across the sky. Light bends through the atmosphere, refracted and scattered, carrying our communication between ground and orbit. Each packet of data is an echo of intention, a fragment of human will translated into motion. When that motion returns as knowledge, we recognize ourselves in it. The two opposing sentences of this block hold that recognition. We depend on what we cannot see. We understand by making the unseen visible. Both are true, and both define the boundary of awareness. Science extends that boundary outward, measuring what was hidden, clarifying what was diffuse. But every discovery eventually becomes background, absorbed into familiarity. That is the cycle of knowledge: revelation, integration, invisibility. Starlink represents a new layer of that cycle. Orbit, once the domain of astronomy and exploration, is now infrastructure, unseen yet vital. In that shift, human perception expands again. The sky is no longer above, it is within. From this perspective, the planet itself becomes a single extended system. Atmosphere, magnetosphere, orbit, signal, all parts of one living continuum of energy and information. Our networks are not separate from nature, they are its newest expression. Physics remains the same, the application has evolved. The insight feels almost quiet enough to miss. The more connected we become, the more the world behaves as one thing. The illusion of separation fades. Distance still exists, but delay no longer defines it. We are, at last, witnessing the physical unification of human experience, not through ideology, but through radio. Every beam of data crossing the sky is a fragment of a shared awareness, a step toward a single field of communication. Yet still, within that responsibility lies peace. We have learned that to be connected is not to be perfect, but to remain coherent. The planet breathes through motion, and we breathe with it. The invisible network endures not because it resists failure, but because it learns from it faster than it falls apart. Knowledge, in this light, becomes not possession, but participation, the act of staying aligned with what moves. And so, as the satellites continue their endless orbit, the world below continues to think, speak, and remember. Connection persists. Silence holds it. The sky above remains quiet, invisible, complete. Every technological age has its signature geometry. For the ancient world, it was the horizon, the line that divided known from unknown. For the industrial world, it was the grid, straight, ordered, built across the land. For the digital world, it is the sphere, the roundness of Earth racked in communication. Starlink completes that geometry. For the first time, the planet itself functions as a single connected surface. There are no blind zones now, no unreachable points. Wherever a dish can see the sky, it can reach the world. This fact seems ordinary to anyone who has grown up online, but it marks a quiet turning point in civilization. Connection has shifted from infrastructure to environment. Orbit has become part of the human habitat. From above, the system is astonishing. Thousands of satellites move in concentric shells around Earth. Each orbit is a ring of synchronized motion. Together they form a sphere of motion, a global shell of communication enclosing the biosphere. If we could see radio waves, the planet would glow. Bands of invisible energy would ripple from every ground terminal, curve through the atmosphere, and meet the lattice of satellites above. They would merge and pulse, forming an electromagnetic aura that never sleeps. This aura is measurable. Instruments detect it as a faint haze of radio energy around the planet, the signature of constant transmission. Earth now emits more artificial radio brightness than any other known world. To an observer light years away, our planet would flicker with patterns too regular to be natural. It would reveal that intelligence has wrapped itself around a sphere. That realization reshapes how we think about scale. Once, global meant distant, abstract, unreachable. Now it means immediate, the default scale of interaction. The curve of Earth no longer defines separation. It defines unity. From space, you can see this unity literally. Night on one continent becomes day on another. As one region sleeps, another sends its data skyward. The satellites, moving faster than any time zone, weave these rhythms into a single continuous pulse. The planet beats in information, synchronized by orbit. That rhythm is physical. Each beam of data interacts with weather, ionization, magnetic fields. The network senses the state of the atmosphere by how signals scatter. In effect, Starlink also observes Earth. Its operation produces an accidental map of air density, humidity, and radiation, a portrait of the planet drawn in radio. Here, technology and science intertwine. A system designed for communication becomes an instrument of observation. The same signals that carry speech also carry environmental data. We connect and we learn. This duality of purpose mirrors an older pattern in discovery. Telescopes built to observe stars also revealed planets. Particle accelerators built for physics birthed medical imaging. Starlink, built for communication, becomes a sensor network for the Earth itself. The visual pulse of this realization is cinematic. Imagine the planet at night, continents outlined in gold, oceans dark, the faint arcs of satellites gliding in silence above. Between them flow invisible lines of energy, messages, images, knowledge, all crossing the curve of the world. The scene is both mechanical and alive, light and motion, orbit and gravity, purpose and chance. It is easy to overlook the physical truth within that image. Every byte of data has mass, carried by photons, transmitted by antennas that generate measurable pressure on their surfaces. The planet's electromagnetic halo is not metaphor. It is a real, dynamic field of energy encircling the world. Connection is now part of Earth's physical weather. The system works because it accepts that weather. Solar radiation distorts, lightning interferes, auroras flicker through signal paths. Yet the network endures. It bends, compensates, and continues. Resilience has become the condition of continuity. From orbit, The Earth's roundness no longer divides land and sea, day and night, nature and machine. It unites them. The surface and the sky are now components of one living circuit, a planetary loop of cause and effect, signal and response. At human scale, this manifests as ease. A call from a polar station connects as easily as from a city. An island once cut off by geography becomes digitally central. Distance loses meaning, replaced by latency measured in milliseconds. The sphere has achieved symmetry. Yet even in this triumph, fragility persists. The same orbit that sustains the network is finite. Too much debris, too many satellites, and the balance could break. Each success adds risk, another paradox in motion. Still, for now, the system holds. The satellites orbit, the signals flow. The planet hums with quiet coherence. The roundness that once hid knowledge now radiates it. For the first time, Earth knows itself in real time. Every curve, every coast, every cloud line traced by passing data. A species has wrapped its own planet in awareness. The sky is no longer above us. It is around us. And through that realization, the horizon ceases to divide and begins to connect. Every beam of data that leaves a Starlink terminal carries with it a record of the environment it crossed. Atmospheric water vapor absorbs part of its spectrum, charged particles refract its path, magnetic fields alter its polarization. To keep functioning, the system must measure all of this continuously. That measurement forms a secondary layer of awareness, an environmental sensor embedded in communication itself. Each connection doubles as an observation. The planet speaks, and the network listens. The architecture behind this is called adaptive modulation. Every satellite monitors the signal-to-noise ratio of its links and changes its transmission pattern in real time. When the air thickens with moisture, it raises power slightly. When interference grows, it shifts frequency or polarization. Each adjustment is a data point describing local atmospheric conditions. Across thousands of satellites and millions of terminals, those data points accumulate into a living model of Earth's upper atmosphere. It updates itself continuously, faster than any dedicated weather satellite can manage. The system becomes a planetary mirror, not just transmitting information, but mapping the medium through which it moves. This mechanism was not designed for science, but it produces science. Researchers already analyze Starlink telemetry to study ionospheric storms and radio scintillation. The network's very struggle to remain stable provides insight into the forces that disturb it. Disruption becomes discovery. From a systems perspective, this feedback loop closes perfectly. The network learns from the environment that challenges it, then uses that learning to maintain connection. It is a form of technological homeostasis, communication that self-corrects by sensing its own distortions. At global scale, this balance depends on distributed computation. Every satellite runs machine learning models that predict interference patterns and orbit dynamics. These models update through cloud synchronization with ground servers, creating a shared, evolving intelligence distributed across Earth and space. It's not consciousness, but it behaves like adaptation. Imagine this process visually. A satellite detects a burst of solar radiation. Its sensors register increased ionization. Milliseconds later, neighboring satellites receive that information and adjust their parameters preemptively. The entire shell responds as one organism, flexing its geometry to preserve communication. The system's responsiveness is not magic. It is physics scaled to computation. Time delay is the enemy. Prediction is the solution. The satellites operate slightly ahead of reality, anticipating the next state of the sky. In doing so, they create continuity across unpredictability. The mechanism extends below. Ground terminals, too, contain layers of intelligence. Their phased array antennas detect the micro-variations in signal phase caused by terrain and obstacles. They adjust beams electronically, steering around trees, buildings, and even temporary interference from birds or planes. Each correction is logged, adding to the shared knowledge of how the world obstructs or distorts transmission. This feedback, multiplied globally, becomes a planetary dataset of transparency and opacity, where signals pass freely and where they struggle. It reveals an unseen map of radio weather, invisible currents flowing through the atmosphere like wind. From an engineering standpoint, the elegance lies in using necessity as instrument. To stay alive, the network must sense. By sensing, it learns. By learning, it sustains. Communication and observation merge into a single act. That merger carries implications beyond science. It redefines how infrastructure and environment interact. The system doesn't just exist in nature, it interacts with it, exchanging data in both directions. The satellites depend on sunlight, the atmosphere, and magnetic fields, while also illuminating them with measurement. It's a loop of dependence, not domination. This mechanism of reciprocity reveals a new type of engineering, one that treats variability as collaboration. Rather than eliminating uncertainty, it integrates it. Each orbit becomes a negotiation between order and chaos, precision and drift. And from that negotiation, continuity arises. Energy flow completes the loop. Solar panels convert light to power. That power drives data. Data creates prediction. Prediction reduces waste. Efficiency becomes awareness. The network's design ensures that adaptation improves survival for both machine and user. Energy spent becomes knowledge gained. At planetary scale, this process begins to resemble metabolism. Energy in, information out. The planet consumes sunlight and emits understanding. Technology joins the carbon cycle in a new form, the information cycle. If we could visualize this in motion, we would see waves of adjustment rippling through orbit, invisible corrections aligning thousands of machines across the globe. Each pulse of change maintains balance, much like heartbeat and breath sustain life. This mechanism connects not only people, but also their data about the world. Sensors in remote regions transmit climate readings through Starlink. Ocean buoys, polar research stations, wildlife trackers all feed into the same web. The network that began as communication becomes a nervous system for the planet. The paradox of this mechanism is that control emerges from humility. Starlink works precisely because it cannot dictate the environment. It must learn from it. Adaptation replaces command. Understanding replaces enforcement. In that replacement lies quiet wisdom, the same humility that guides scientific inquiry. Observing before assuming is built into the network's core logic. It survives not by power, but by sensitivity. From the silence of orbit, Earth's weather, light, and motion flow through data. The satellites move, the air shifts, the signal bends, and the system corrects. Each correction, a whisper of understanding between matter and machine. The planet breathes information now, and the network listens. Every connection adds awareness, and every layer of awareness makes the source harder to see. The more precisely Starlink learns to listen to Earth, the less visible our role becomes. We build the sensors, but the system learns on its own. We launch the satellites, but they adapt beyond our notice. This is the paradox of automation in orbit. The sky we control no longer asks for control. It adjusts, predicts, and corrects faster than human reaction. It sustains communication even when we sleep. We wanted connection to make us present everywhere. Instead, it makes us unnecessary in its operation. The planet speaks directly with its machines. Each update, each beam, each handoff occurs autonomously. Human oversight remains, but increasingly at a distance, statistical rather than direct. Engineers monitor patterns, not actions. The constellation has become self-regulating. The contradiction is subtle but profound. We've built a network to serve us, and in serving, it learned to serve itself. Every adjustment designed for reliability reduces dependence on human timing. Each layer of stability removes another layer of perception. From the ground, connection feels immediate, but immediacy conceals mediation. Every second of apparent simplicity contains thousands of invisible corrections. The signal becomes smoother as the process grows more complex. Perfection hides the effort that creates it. At this stage, the network embodies a scientific mirror of consciousness. It has no awareness, yet it models awareness. Constant monitoring, prediction, reaction. It resembles the mechanics of thought stripped of experience. It functions as a memory without memory. Here the paradox sharpens. The closer we come to perfect connection, the less we appear in it. The system's intelligence does not replace ours. It dissolves into the background of our world. the way the nervous system fades from awareness until it fails. We live within its operation as effortlessly as within gravity. The thought experiment is simple but unsettling. Imagine disconnecting the entire constellation for a single hour. Silence would ripple through supply chains, navigation systems, research stations, disaster relief, personal communication. The world would feel smaller, slower, fragmented. Yet within that silence we would remember that continuity is not a given. It is an act maintained by invisible precision. Dependence and detachment now coexist. We depend absolutely on a system we rarely think about, and we have detached emotionally from the infrastructure that defines our reality. This emotional absence is new. We once marveled at machines. Now we expect them to vanish behind usability. Starlink fulfills that expectation perfectly. Its greatest success is to disappear into the everyday. But in doing so, it reveals the paradox of progress. The more seamless technology becomes, the less we sense the limits it overcomes. Every technological age has hidden its labour. The steam engine masked combustion behind motion. Electric grids hid generation behind the flick of a switch. Starlink hides orbit behind the appearance of instant presence. Invisible effort becomes the texture of civilization. From orbit, the contradiction is visible. The satellites move in strict choreography, exchanging light across darkness. Each maneuver is deliberate, but none of it carries emotion. Below, billions of humans feel connection, but not motion. The beauty of alignment has no witness except the system itself. There's a philosophical tension here. As we extend intelligence outward, does our sense of participation contract? The sky once inspired wonder because it lay beyond our control. Now it functions because we have filled it with control. But wonder resists ownership. To control everything is to risk losing the capacity for awe. Yet awe persists, if seen from the right angle. It hides not in distance but in scale, in knowing that coordination of this magnitude happens at all. Silently, precisely, perpetually. A civilization capable of synchronizing thousands of moving points at orbital velocity expresses something rare. Understanding turned into rhythm. Still, the network remains fragile. It depends on power grids, launches, maintenance, and the stability of societies that build it. Its autonomy is only apparent. Beneath it lies an infrastructure of human collaboration. The paradox is that dependence hides under independence, just as invisibility hides under function. Perhaps that is the real shape of modern knowledge, recursion rather than resolution. Each layer of control reveals another dependency. Each illusion of freedom rests on an architecture of care. From the night sky, you can glimpse this tension embodied in motion. Satellites drift across constellations, each one momentarily bright, then fading. For that instant, it reflects sunlight from a star that existed long before the machine that now redirects it. Cosmic and human light merge, indistinguishable. Connection becomes communion. Technology becomes extension. Awareness becomes distributed. Two opposing sentences describe the heart of the paradox. We have never been more connected. We have never been more absent from the systems that connect us. Both are true, and both sustain each other. Presence requires absence, just as communication requires silence between signals. In that silence lies the quiet wonder of our age, a civilization that learned to wrap its planet in motion so seamless it vanished from view. Above us, invisible geometry continues. The satellites orbit, the signals cross, the planet hums. We are inside the mechanism now, not outside it. And though we cannot see it, the system remembers us. In every transmission, every beam, every return of light. In the silence between transmissions, the world keeps thinking. Signals cross, data flows, and yet no one feels the movement. The network functions without spectacle, like breathing. In that invisibility lies the highest form of design. Technology so aligned with nature that it vanishes into it. Starlink has become an expression of collective intelligence, not because it thinks, but because it synchronizes. Every satellite, every terminal, every orbit acts in rhythm with the rest. That rhythm is the signature of understanding turned into motion. The insight that emerges is simple and immense. We have built continuity out of impermanence. Nothing in the system is still, yet everything holds together. That balance is not illusion. It is knowledge embodied as practice. The satellites teach by example. They never rest. Each orbit decays, each path corrected, each alignment renewed. The lesson is the same for physics and for humanity. Coherence must be maintained, not assumed. To stay connected, we must keep adjusting. This truth reaches beyond technology. It describes life itself. Dynamic equilibrium across instability. Cells repair, ecosystems adapt, civilizations evolve. The network in orbit simply mirrors that universal pattern at mechanical scale. When engineers describe the constellation, they speak in terms of uptime, latency, coverage. But beneath those metrics lies a more profound measurement, the precision of cooperation. Thousands of machines built by thousands of people, operating under one logic, one purpose, one planet. The act of coordination becomes the meaning. That meaning reframes progress. For centuries, progress meant conquest, faster, higher, further. Now it means harmony, stable, balanced, continuous. We are learning that sustainability is not stasis but rhythm. The network's survival proves that motion, when tuned, can be peace. From orbit, Earth's beauty is not its stillness, but its recurrence. Clouds forming, oceans circulating, light shifting across continents. The satellites trace that recurrence with their own cycles. They rise, fade, and rise again, like artificial tides. The planet and its orbit breathe together. This shared motion dissolves the boundary between natural and artificial. It reveals that technology is not an exception to nature, but one of its outcomes. We are not outside the system, we are its latest experiment in self-organization. The paradox that once separated presence and absence now resolves. We are absent only in form, present in function. Our awareness lives inside what we have built. The network is not other than us. It is the physical extension of our need to remain aware of one another. Two opposing sentences capture the essence. The more invisible connection becomes, the more it defines what is real. The more we surrender control, the more continuity we gain. Each satellite in orbit is a monument to precision, but also to humility. It accepts gravity, drag, sunlight, and decay, the same forces that shape every living thing. It doesn't resist them, it negotiates with them. That negotiation is its intelligence. Knowledge at this scale is no longer contained in any single place. It exists in the relationships between moving parts, the alignment of frequencies, the timing of orbits, the predictability of patterns. It's not stored, it's sustained. The constellation teaches that knowing is an active state, not a possession. If we could listen to the network, it would sound like stability made from motion. A low, unbroken hum of compensation. That hum is civilization's new heartbeat. It speaks of a world that has learned to stay coherent through constant change. Look down from orbit, and the planet appears serene, wrapped in thin atmosphere, luminous in reflected light. Within that calm sphere, everything moves. Water, air, signals, lives. Stability is not the absence of motion, it is motion in agreement. That is the quiet logic Starlink embody. The same logic applies to knowledge itself. We often seek final answers, but truth, like orbit, is circular. It refines itself through return. Every discovery leads to a new equilibrium, temporary but sufficient. Science, like the satellites, stays aloft by falling perfectly. The network's persistence reminds us that progress is not linear, but orbital. We advance by revisiting, each loop higher in understanding, wider in scope. Starlink's constellations are not steps toward the stars, they are revolutions around what sustains us. Connection as continuation, not escape. From the ground, the system seems distant, but the data that flows through it, voices, thoughts, dreams, is profoundly human. Orbit holds the evidence of our curiosity. Every message transmitted is a small act of remembering that someone, somewhere, is listening. This awareness circles back to humility. For all its complexity, the network remains fragile. Debris can scatter, solar storms can rise, gravity will always win. Every orbit ends. But the pattern remains, rebuilt, renewed, relearned. That persistence is the definition of knowledge. We survive by remembering how to rebuild what we lose. Starlink is not permanent. It is proof that continuity can exist without permanence. The same truth guides ecosystems, cultures, and consciousness. Endurance through renewal. Order through change. From this vantage, the old boundaries dissolve. Between human and machine, between planet and orbit, between signal and silence. All merge into one continuous process of adjustment. Connection becomes a law of physics, not just an invention. In the quiet of night, as satellites pass unseen overhead, the world's thoughts flow within them. No sound, no motion perceptible, just invisible coherence. That coherence is what knowledge feels like when it no longer needs to prove itself. The planet turns, the orbits glide, the sky remains calm. We continue, thinking, sending, receiving. Part of a larger system that mirrors the same logic as the universe itself. To stay whole, keep moving in harmony. And through that motion, the curve of Earth, once our boundary, has become our link. At night, the sky looks calm again. The satellites are still there, but they have dimmed beyond casual sight. Only the stars remain, steady and ancient. The curve of Earth turns quietly beneath them. We stand on that curve, wrapped in invisible connection. Signals cross oceans and mountains unnoticed, effortless. The network holds, and through it, so does our sense of nearness. Starlink should not work on a round planet. By geometry alone, it should fail. But the world does not yield to geometry. It moves, and in that movement lies the secret of continuity. We learned that a signal can survive the horizon if its source never stops moving. We learned that motion can be stability, and that silence can be structure. We learned that connection is not a line, it is a rhythm. From orbit, Earth glows as one organism, blue, white and gold breathing through light. The satellites trace its pulse, whispering data from one horizon to another. They form no fixed pattern, yet together they describe wholeness. Every orbit is an act of trust. Trust that gravity will hold, that prediction will remain true, that the curve will not betray the line. And every moment of connection on the ground is a reflection of that same faith, translated into human form. The curve that hides us also unites us. It gives shape to distance, and distance gives meaning to connection. The network exists because the world is round. It works because we have learned to move with that roundness, not against it. In the end, Starlink is less a story about satellites than about perspective. It reminds us that our limits are not walls, they are geometries to understand. Every horizon is a challenge to coordinate, not a boundary to break, and every signal that crosses it carries a trace of that realization. The science is complete, the paradox resolved, the knowledge returned. What remains is a quiet awareness that the sky above us, once unreachable, now hums softly with our own reflection, that the universe we study has begun to include our presence as part of its light. Look up, and you might see nothing. That is how you know it's working. The invisible has become continuous. The impossible has become ordinary. The planet has learned to speak across its own curve and to hear itself in return. The sky remains vast and calm. We remain within it, connected by motion, held by gravity, bound by understanding. And in that balance, between what moves and what endures, the world stays whole.